Yippee! So yeah, we're starting with our inverse functions. Reflections about the line y equals to x are just a simple definition of what inverse functions are. This is not quoted from any textbook, guys. I mean, you'd probably find a lot of definitions of this in a lot of textbooks, but this is just a simplified version of the definition. Just inverse function is simply just a reflection above the line y equals to x. Reflection above the x-axis, reflection above the y-axis are grade 11 concepts. This one is a grade 12 concept, inverse function, which is just the reflection above the line y equals to x. This one is interesting because when you find the new function of this, it's going to be a bit different and a bit challenging to do, especially when it comes, and it requires like some new concepts so that you can some new concept that you have to be familiar with so that you can treat the question in full. So for an example, let's do the easiest of them all, linear inverse functions. So with linear inverse functions, let's start there. It's a function, right? So therefore we are not necessarily just reflecting a point, but now we are reflecting the whole graph. So if you don't know how to draw a linear graph, then it's going to be quite tricky to draw a linear inverse graph. So I will assume that you know your grade 11 stuff, right? And if you don't, you can check out other videos where I did grade 11 graphs and right? Or you can just book a session and blah, 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 blah. Details will be on the link or in the description. I'm treating this video like it's on YouTube. I hope it will be. So yeah, linear inverse functions. When we have, let's say for an example, you have a function which is f of x is equals to let's say 2x plus 1, right? If it's 2x plus 1 and it's an f of x, remember f of x is y, right? So I will rewrite this and I will say y is equals to 2x plus 1. Now this is the original function. The inverse function will be represented like this, guys, like this, like this. Then you say of x is equals to, then yada yada yada, right? So what you're going to write here will be the equation of the inverse function. This function is basically this one having been reflected above this line. Remember, when you have a Cartesian plane on the side and you draw this, if you draw a straight line, for example, like this, its inverse function will probably look like something like this. But we'll see how we get there, right? Because it's reflected above this line. You'll see. So this one probably would be this one, and this one would be the original, right? So let's look at, remember, I haven't really drawn this as this specifically. We'll draw the real one, this one. So now I will say this is our original function. If I want the inverse function, I will start by writing this. Let's say the question said, determine an inverse function of this. Your first step would be y is equals to 2x plus 1. Then you write this just to show that you are determining an inverse function. Just say inverse y is equals to x. Basically, you are meaning that you're going to reflect this above this line, right? So when you're done writing this, now you interchange x and y. Where you see x, you write y, and where you saw y, you write x. Easy, ne? So guys, remember when we had a point and which was like 2 and 3, when we got our new point, we said 3 and 2. Basically, we swapped. The 3, which was y, became the x, and the 2, which was x, became the y. So even in the function, guys, the x, which was x, now becomes a y, and the y, which was y, becomes the x. So I will substitute y by x, and I will substitute x by y. Then I have this. Then remember, a function, I would say a function is only readable or only comprehensible when the y is the subject of the formula. So now the next step would just make, you would just make y the subject of the formula by applying algebraic manipulations, transpose, divide by coefficient. So when I transpose, I will have x minus 1 equals to 2y. I divide by 2, divide by 2, divide by 2. Then I would say y is equals to what? Half of x minus 1 over 2. I say half of x because x over 2 is the same as half of x, so that I can get my gradient and my constant. So I can draw this and I can draw this. This is the original, this is the inverse. So I can represent it like this. Once I make y the subject of the formula, I will write this. Or I will present it in this way, and I would say what? F of this of x is equals to 1 over 2x minus 1 over 2. So this is the inverse function of this. Inverse. Yippee, then we found our inverse function. So if they say draw the inverse function of this, especially because it's a linear inverse is simple. It is also a linear. Therefore, if you know how to draw a linear, you can just draw this one. You will treat this as your y, and you will treat this as your gradient, and this is your constant. Your constant is the y-intercept, and now to get the x-intercept, you let your y to be 0 and solve for x. Then you just plot the two x-intercept and y-intercept and connect them. You might also draw the original. So let's draw them. Let's just draw them for the fun of it. Let's assume you know how to draw graphs. So for this one, my y-intercept is, let's say we have 1, 2, 3. My y-intercept is 1, and my x-intercept would be 1. What? I will transpose 1. I will have -1 and divide by 2. It will be -half. Therefore, if I had a -1 here, my -half would be here, right? And I connect them. So this is my original function, right? Now, this is our line y equals to x here, right? Y equals to x. Let's reflect it. I will draw this one. With this one, my constant now becomes a -half. So if I had a -1 here, my -half would be here, -half, right? Then to get the x-intercept, I will let y to be 0. I transpose, I will have half. Then I divide by half both sides, which means my x-intercept would be 1. Therefore, I would, if it's 1, 2, 1, it will be my x-intercept. Then I will draw it here. If it cuts here, it's also going to be like this. You see? So there's something interesting, guys. Like there's always something interesting about this. The two functions, especially for straight line, right? The two functions, the inverse and the original, will always intersect where the y equals to x graph also cut both of them. So wherever you see the y-intercept going, these two functions will always intercept at y equals to x. That's the interesting thing. If they don't intersect at this line, then there's something wrong with your graph. So this one is the original, this one is the inverse. You can see it went like this. Da-da-da. You see? This is your inverse function. You just swap the x. Remember, you swap the x with the y. Then you make y the subject of the formula. Then you have your function. Ta-da. Then you draw it the way you draw the original. Then you have your inverse for linear. Now we're going to move on to our parabolic inverse functions. Ready?